Welcome to Module 3, the future of EV batteries. If Module 1 and 2 showed you how today's batteries work and what really affects their lifespan, this module takes us into the future, the breakthroughs that are coming next. From solid-state batteries that promise faster charging and safer chemistry to recycling and second life projects that give all batteries a new purpose, to cost trends that are making EVs more affordable every year. These advances will shape not just cars we drive, but also the energy systems we live in. Let's explore what's coming and why the future of EV batteries looks brighter than ever. Let's begin with the most talked about breakthrough, solid state batteries. Today's EVs use lithium ion batteries with liquid electrolytes. Solid state replaces the liquid with the solid material. Why does this matter? Because solid electrolytes are more stable, less flammable, and allow for higher energy density. That means three huge benefits for drivers: more range, potentially 30 to 50% more than same size battery; faster charging, some prototypes promise a full charge in under 15 minutes; greater safety, no flammable liquid, less risk of fires. Now, here is the reality check. Solid state batteries are still in development. Companies like Toyota, Quantum Space, and BMW are testing them, but large scale production is not expected before the late 2020s. The main challenge is cost and manufacturing. Think of it like the early days of flat screen TVs. Amazing technology, but the first ones were extremely expensive. Over time, the cost came down, and today flat screens are everywhere. Solid states will likely follow the same path. Now let's talk about what happens when EV battery reaches the end of its first life. First, recycling. EV batteries contain valuable materials like lithium, cobalt, and nickel. These can be recovered and reused, reducing the need for mining. Companies like Redwood Materials in the US and Recycle in Canada are already building large recycling facilities. Second life. Even when an EV battery is no longer powerful enough for driving, it usually still has 70 to 80% of its capacity left. That's perfect for stationary energy storage, like powering homes, offices, or even the electrical grid. A great example comes from Japan, where Nissan reuses old leaf batteries in street lights and buildings. Another example, some solar companies repurpose used EV batteries for home backup systems, giving them another 10 years of useful life. So instead of being waste, EV batteries become part of the circular economy, used once in cars, then again in energy storage, and finally recycled to extract raw materials. Now let's look at one of the most exciting trends: cost. Back in 2010, EV batteries cost over $1,000 per kilowatt hour. Today, prices have dropped by almost 85%. The industry is getting closer to the magic number of $100 per kilowatt hour. Why does that number matter? Because it's seen as the tipping point where EVs become as cheap or even cheaper to build than gasoline cars. Of course, there are bumps along the way. Raw material prices, especially lithium, can cause temporary increases, but the long term trend is clear. Battery technology more factories, and economies of scale are driving costs down. For drivers, this means more affordable EVs with longer ranges. We already seeing it. Vehicles that are used to cost $60,000 are now entering the market at 30,000 to 35,000. And in the future, EVs will be accessible to almost everyone. This isn't just about cheaper cars, it's about mass adoption, millions more drivers making the switch to clean transportation. So, what's next for EV batteries? Solid state promises more range, faster charging, and greater safety. Recycling and second life will make EVs part of a sustainable circular economy. And falling costs will bring EVs to the mass market, making clean driving the new normal. The future of EV batteries is not just about technology, it's about accessibility, sustainability, and transformation. In Module 4, we'll get practical. A simple owner's guide, how to extend your battery life, what to check when buying a used EV, and the charging habits that make the biggest difference. See you there.